Hey, good afternoon, everyone. Welcome to the third part of our Lunch and Learn series, where we've been looking at building a modern data analytics platform. I'm James Green. I'm the head of data analytics and AI at Tancorus. Today's session, so the final one of the three, it's all about visualizing this information. So if you think about it, we've invested time, energy, CPU cycles, getting all of this great stuff on the left here. So we've got these high value insights. Obviously no good if we can't serve them to the people that actually need them to take some kind of action to get some kind of value. And that's what we'll be looking at in this session. We're going to be focusing on Looker. And we're going to be looking at how you can get insights with Looker, how you can help engage business leaders. So we're looking at some different dashboard examples. And then we'll also be covering embedded analytics, which is a really key use case for Looker and what we're seeing increasingly across clients. And then my partner, Bailey Sharp-Ledger, he'll be actually showing you a bit of the actual build. So what it looks like from a technical standpoint in terms of building some stuff in LookML. And then I'll be covering more from from an end user perspective. So yeah. Okay, so this is our approach to modern data analytics platforms. So in session one, this is what we covered. These are all on demand, so if you've not seen these, you can go and catch up. But essentially, session one was all about how to get your data using a modern ELT approach into BigQuery, so Google's hyperscale data warehouse. Lots of different technologies that we use depending on the use case of where the data is coming from on the left. Once in BigQuery, we're then looking at transforming it. So we're turning kind of raw data into high value assets. And those assets we further enrich in some use cases using ML. And that was the main focus of the second session. So we explored technologies like BigQuery ML, where you can do ML using SQL, AutoML, where AI actually trains AI, which is pretty cool. And then the more difficult or more advanced areas of AI. So we looked at AI platform, which is now called Vertex AI, and TensorFlow for those kind of very complex use cases. And then today's session is, so it's all around the far right here. So it's all about presenting these insights in a timely and engaging manner to whoever needs them. Alrighty. Okay, so we're going to start off by giving you a quick kind of intro into Looker. So some of you will know what it is, some won't. So I'll presume that you're in the latter group. So this is a very high level. So Looker is a visualization platform. It's synonymous to things like Power BI, Tableau, although it does have considerable advantages over those two particular products. It was bought by Google last year, so it's now officially part of GCP. And really, one part of Looker is kind of like traditional data visualizations, as we can see on the right there. But it's a complete analytics platform, which we'll kind of cover as we walk through the material. And the real aim here is to have a single version of the truth, which is probably quite an overused statement, but it's not until you see a situation where you don't have a single version of the truth. We work with lots of clients where they'll have a retail number, for example, and they'll have 8, 9, 10 different versions of it. And then, and in board meetings, the first 10 minutes is squabbling over whose number's right and why they're wrong. And it's just, it's really, really counterintuitive and kills kind of performance, really. So it's all about having a well-defined, well-governed single version of the truth on some of these key metrics. Now, Looker is completely cloud-based. So there's no server or anything like that. It's all hosted in the cloud, all accessed via your web browser as well. So there's no installing, like Tableau installing, downloading weighty things on laptops and worrying about someone's laptop needs upgrading, etc. It's all just running in a browser. In terms of the architecture, I guess some of the differentiating features of Looker. So there's a semantic layer, which Bailey actually will be looking at a bit later on. The semantic layer is, if you think about, you've got your data living in, say, BigQuery. So that's where we've got our facts and dimensions, our physical database tables. All the semantic layer really does is it sits over that, and it's just defining the relationships between the tables, where the foreign keys are, what the primary keys are. You can do any kind of custom formatting on there, for example, if you want to make links to things. You can put calculated fields in there as well. But the idea is there's no data stored in there, so it's not like like something like Tableau where it's kind of, or Click where it's in memory. It's not doing anything like that. There's never any data in memory. It's purely just to help Looker understand and define what your data structures look like. So the idea is you build out this semantic layer, you build that once, and then you kind of add to it over time. And then when you actually run a dashboard in Looker, rather than, which is a legacy way of doing it, rather than kind of taking data from, say, 2 or 3 tables, and then in memory or on your laptop, it's basically, joining those together and trying to get insights. That's not how Looker's architected. So Looker, I guess, realized the power of modern data platforms like BigQuery. And you can basically, all Looker is doing is generating a single SQL statement that's executed on BigQuery. So yeah, we'll talk through that in a bit more detail, but that's a key differentiator, and it's worth just understanding that. So nothing's been done in memory. So it's all just basically building up SQL. It uses its semantic layer, this LookML layer, to determine what SQL to build, and it fires it off to your modern warehouse, whether that's something like BigQuery or Snowflake, and then returns the results in near real time. And we'll touch on this, but your LookML layer, if you think of it almost like a data dictionary, that's evolving. So as business rules evolves, the idea is you go in there and you change that once, or if you have if you want to get some new data surface, then you would add that into that LookML layer. I won't go into too much detail on this one. Highly scalable and performant. So because it's using the power of those modern databases like BigQuery, it's super fast. So there's no more. I've seen it so many times. I've been doing this for a long time now, nearly 20 years, and working with things like Tableau, Power BI. The amount of times users are just completely switched off because dashboard takes 60 seconds to load, and you've lost them completely. And if you spend all this time building all this analytics, it's really important from the user standpoint that they can get it quickly. Everyone needs data really, really fast now. And people aren't prepared to wait 60 seconds anymore. You'll lose all engagement from your audience. So I imagine there's probably quite a few, heads of data on who've probably lost that or have that limited engagement. And in my experience, slow dashboards basically kill user engagement. Browser based, so it's really simple. There's no, ringing up help desk. I can't install this on my laptop. Is about to take off because its CPU is spiking because it's trying to do something in memory, and all that stuff just goes away. There's no version issues. It's just launch in your browser, launch on your phone, on your tablet, away you go. And really future-proofing, which is a bit of a generic term, but in terms of the scalability, it's going to scale with your data. So it's using things like BigQuery. It's using BigQuery's performance so you could be looking at billions of rows of data, and it's not going to be any concerns on performance. And the high-level architecture. So as we kind of talked around really, so if you think about this is a SQL database, potentially any kind of SQL database, and then Looker sits on top. So we've got this kind of analytics layer, so the modeling layer as it's referred to here. And then the key thing is with Looker is it surfaces an API. So if you think about the ways you can get data out, one is the web interface, which I'll show you in a minute. So this is what we refer to as traditional dashboards, visualizations. So you've got the web interface, and that's going through this modeling layer, hitting your data real time. You can also embed these. So you can take the dashboards, you can embed them using iframes, so you can embed them in your, your intranet pages on your mobile devices. You can schedule delivery. There's lots of out-the-box scheduling, which I'll talk to you about, but you can also do lots of custom things here. So you can, send this data, for example, if you've got like a marketing tool and you've got a particular audience, maybe I've identified an audience of 1,000 people, slicing and dicing in Looker, I can then create a custom action and ship that out to a third-party marketing tool, upload that audience, and then away I go and start kind of marketing to them. So you can do lots of really clever stuff like that. And then on the right-hand side, there is a REST API, which is really powerful. So what it basically means is you can access this API, whether it's getting data out, whether it's scheduling, and this is really powerful. So if I want to write a custom app, for example, on a mobile phone, and I want to pull some data points from SQL database using the defined once KPIs in here, then I can do that via this API. And if another user's running Looker, looking at a visualization, they'd be looking at that exact same number, that exact same logic. Same with someone who gets, maybe sent that data to the, to wherever. And same with someone who's embedded Looker in, say, and look at it on their iPad. So that's really, really powerful. And if you get that right, it really transforms the way that you do BI. People on the call, some of you might be kind of more from a software engineering, or maybe you're CTO. If you're thinking about, I guess, software engineering best practices, they really apply to data now. So Looker has full integration with Git. So every client project we use it on, typically we'll use GitHub. And you have a repository, and it just means that collaborative team working. You've got full version control. There's no more what changed in this workbook since I last used it, etc. So we really like the way that this is kind of defining. It defines everything as code effectively, even down to the dashboard level. And especially that LookML layer. So that LookML layer, defined once, full version control, which is really, really important, especially when you've got multiple people working on it. So yeah, so that's just a summary of the key features. And what I thought I'd do for this, so cycling is something that most people, they understand. Most of you will be familiar with the Santander cycle scheme, or the Boris bikes, as they're known. Well, we had to Google this. We can remember why, but it's because I think Boris actually kind of paved the way and made this available, or make this possible in London. Is that fair?
He was quite instrumental.
Yeah. So good old Boris, and there he is. Yeah, looks like he's about to fall over in a second shot, but there we go. So what we're going to do, we're going to look at exploring the London Santander cycle scheme. Now, this is a data set that's available on Google Cloud for free. There are hundreds of these public data sets, and if anyone's interested, I really encourage you to go and explore. So you can spin up a BigQuery instance, take you about 30 seconds. You get, I think it's $300 free credits, and you can access all of this data effectively for free. And there's a load of different ones on here. So I've got some examples here. So we've got COVID-19 data sets. Yeah, there's all sorts on here. There's taxi rides in New York. There's a whole load of stuff, weather stuff. But we're specifically looking at the London Santander cycle scheme set. And just at a high level, so there's 781 stations. So a station is just like a drop-off point. So where you either pick up a bike and off you go, or when you finish with your journey, you drop it back at that station. So 781 of those across London, just under 14,000 bikes. And this data set spans just over 24 million journeys. So it's a decent size. All right, so what I'm going to do now, I'm just going to show you Looker. So it's going to go back to the home page. Okay, so this is the Looker homepage, I guess, as a business user. So as you'll note, first thing to note is it's in my browser, as I mentioned. So nice and straightforward from that point of view. And I'll cover the kind of basics really. So on the left-hand side, you've got some simple navigation. So I can look at my recently viewed dashboards. Everyone should know what a dashboard is. They also use terminology like looks. So a look is basically a chart or a table, so a specific visualization within a dashboard. So when I talk about looks, that's what I mean. So we've got recently viewed. You can see my favorites here. You can create boards, you can create folders, which is a really nice way of kind of organizing everything. So what we tend to do in an enterprise situations, we'll organize things generally by business unit. So you can imagine you've got, marketing, you've got supply chain, etc. And there's a really granular business model, a security model in Looker, so you can permission, who gets to see what. So organizing your dashboards and your explores, we'll cover explores in a minute, is really important just to help people kind of navigate, and importantly, self-serve. So self-serve is something that Looker have invested a lot of time into making possible. And I think Looker is probably the only tool I've ever seen business users actually proper self-serve. So yeah, and I can show you how easy that is in a minute. Right, okay, so we're going to start looking at the Santander cycle scheme. So just while I'll come back to here a second to give you so essentially what we did, we ingested the raw data living in BigQuery, so it's on that free public data set. In this example, we use DBT, which I'll touch on in a little bit actually. So we use DBT to do some SQL transformations on top of that raw data to pull out some key insights. So we've built a traditional star schema model, which still applies. So we always use Kimball. So we've built a number of facts. So for example, there's a journey fact, one row for every cycle journey. There's things like there's a station dimension, for example, tracking history. And then Looker sitting over the top. So if I click on cycle scheme overview. So as a user, I come in here. Now this is uncached, and you can see that's looking at those 23 million. That it's effectively over that fact table. So that's it's pretty quick, right? And it's fully loaded all of that data. So looking at this, we've got some high-level metrics at the top and these nice, clear-to-use tiles. So we've got our key metrics that we just discussed there, 23 million journeys. Most journeys in a single day, 70,000. Lots of different visualization types. So here we've got, these are quite good actually, as trying to familiarize a user who might never have seen this data before. This is the entire data range, so from Jan 15 through to what is that? Where's that? So that's the June 17. So we've got a couple of years worth of data. I can see the kind of, I can see the general trends on here, which is really clear. I can instantly see some data gaps. So we've got a big gap there. Don't know why it's missing in the public data set. And what's interesting on charts like this, which is really useful, is you see these two big spikes. Now this is either a data quality issue like this, which is probably what I would explore, but actually the reason for these is these are actually the tube strikes. So in London they had 2 tube strikes. For those of you, including myself, who were working in London at that time, yeah, that was not a good day. And you can see that, no surprise, there's no tubes. Everyone, well, a lot more people jumped on a bike. So we had 70,937 journeys on that day. So on the 9th of July 2015. Now the nice thing with Looker, if you think about, because there's no kind of in-memory merging going on, he's not having to worry about data volumes which is traditional BI, suffered with. You had to aggregate everything. You couldn't necessarily, just live explore over 23 million records. This could easily scale to, 1 billion records and have no issue on BigQuery. There's no way you could do that on something like, on say Microsoft Stack. It just wouldn't scale. So nice thing with Looker is because you can effectively get right down to the raw data. So if I look at this, I can click on this bar, and you can define drills, which is really neat. And from a technical standpoint, you define these in your LookML layer, what you want to drill by. So in this one, I can drill. I haven't gone down to the journey level in this example. I've summarized it, but you can do. And I'll show you with another example of cash flow forecasting where we drill down to the invoice level. But you basically define the grain. And here you can see it's actually drill. So it's aggregated to the hour. And no surprise, my peaks on that day were 5 o'clock, so around kind of commuting time in the evening, and 8 o'clock in the morning. Now, from here, I can do a number of different things. So I could download this if I wanted to. So I can download to spreadsheet, CSV, JSON. I can do it as a PNG if I wanted to, to send this to someone. But what's interesting is you can explore from here. So as a business user, I might be interested on this particular day. So I click on the Explore. And this brings you into, this is really the self-serve interface that's available in Looker. So what you've basically got here is on the left-hand side, I've got the various different kind of data points that I can browse from. And this is what's defined in your LookML layer. We can talk about a few best practices, but basically you want to make sure these are nicely grouped, and less is more. So the fewer data points you bring in here. So if I look at cycle stations, and actually, to be fair, I haven't cleaned these up very well, partly just to show you why it's important to bring as few of these through as possible. So if I look at cycle stations, I've got, for example, I've got a name here. Okay, so name of the cycle stations, it might be Kensington or Waterloo. But you see, I've also got a terminal name. Now, if I was to review this from a data, from a data perspective, I would, flag that as a real issue, right? Because if I'm a user, I'm looking at this and I think, well, why is there two names? What's the difference between a terminal name and a name, and causes confusion? So what you should do when you're defining your LookML layer, really think about reducing the number of these attributes. Okay, and every one of these that you bring in, we always say it has a tax. So the tax on it is maintaining it. It's making sure it's correct. It's fielding questions from users, okay? So you really want to, as I say, less is more. Don't do it the old way, which is to present everything and look how clever I am. I've got 500 attributes about a station. Your business user is going to look at that and say, this is unmanageable. I don't know what I'm looking at here, and you've lost engagement. So really think about that. This is how this is organized. So you break these up logically. So we've got stations, we've got our date dimension, which has lots of different information on the particular day that you can break into, on and above what you get in Looker by default. And then this is our, so we have a fact table behind the scenes that's building an hourly snapshot. And I can look in here and you can see I've got things like station name, lots of different, so is it raining or not? So lots of different kind of attributes. On the right-hand side, you can see what this is currently bringing back. So you can see we've got snapshot, hourly station, so basically the time of day and the hour, and we've got how many journeys took place on that hour, and you can see the results here. And if I click on the visualization tab here, I can see this, and I can change loads of different visualizations. You can define your own using JavaScript DS3 if you want to, but from a user's perspective, you tend to start out with kind of looking at what question you want to ask. So what I thought would be a good one on this is, okay, I'm interested to see what the stations look like. So say I want to see the top 10 stations on that day. So if I want to do that, really simple. So I know it's station information that I want the name. So I just click on the name, and that brings it in on the right-hand side there. Now, I want to do a top 10, so I just say, okay, I only want 10. I click on this to sort it, and then I click run at the top. What that's done, not from a user's perspective, so I think technical people on the call, perhaps, I can go on here and look at the SQL that generated. Okay, really useful for troubleshooting. So if you have any odd data that comes back, you can easily capture the actual SQL. But from a business user's perspective, they're not really interested necessarily in that. But I can see here I've got my my cycle station. So I think, okay, that's pretty cool. So I go up the top here. Now, personal preference, I always like top 10s on a vertical, on a horizontal histogram like this. So I think, okay, so I think that looks pretty good. Now this is a bit odd. I can see I've got the station name there, which is nice, but I've also got this date, which doesn't really make sense. And that's because down here, the blue columns here, the dimensions, if you like, what you're slicing and dicing by, I've got 2 there. So that's why Looker is displaying those by default. All I need to do is I click on this little cog. I can hide that one. Okay, so I've hidden that. Okay, that looks a bit better. Personal preference again, now isn't a menu here. So this is different to every visualization type. So lots of different stuff you can do on this. But one of the things I personally think is really useful with these horizontal top 10s is to actually show the number. So I'll put that on there. If I click on run, I hide this. We can collapse this if you want to. And there's my top 10. Okay. And I guess no surprises there. I mean, we've got King's Cross at the top, which you kind of expect. The big rail, stations next to the big rail stations, Waterloo, Soho, interestingly. So I guess that's probably a lot of businesses / tourists coming out of Soho. So really interesting there. And now when I've created this as a user, I've got a number of different options here. I may just say, you know what, this is really interesting. I've got what I need and come out of here. That's fine. Other options I could do if I right click up here. So I could save this as a look. So if I think this is going to be something useful for my team, for other people to use, maybe I want to add this to a dashboard later on, then I can save it as a look. I can save it to a dashboard. So if I think if this is actually really useful to have on that dashboard I just used or another dashboard, then I can save it there. I can download it. So if I click on that, we get different options again. So I can get this into, if I can get this to a spreadsheet if I really want to. Let's go back up here. I can save and schedule it. So this is quite interesting. So if I save this as a look, so this might be my strike top 10. So I'm going to save this into you can see here the different folders. This is my own private user folder. We might have a my team folder set up, so I might want to share that. So you kind of choose where you want it to go. If I click on save, then it'll take me to the scheduling piece. There's loads of different scheduling options that come out of the box. So for example, I could schedule this via email. So these are default options. I can send it to a webhook. So if you want to do something clever with that data, then you can send it to a webhook, and that can basically potentially do anything with it. I can send it to Amazon S3, SFTP server, and you can create what you call custom actions. So if you want to, for example, send this to maybe a marketing suite, or there's lots of different plugins and custom actions that you can use, or you can develop your own and they will appear on the right here. If I'm going to tick email, who am I going to email this to? What kind of format do they want? So I choose that, and then I schedule using these different frequencies, and away I go. So yeah, really, really simple. So I cancel out of that if you want to actually do that. Hopefully that kind of gives you an idea. It gives you an idea of the kind of the self-serve and how these kind of explores are constructed. Okay, so if I go back now, so I'm actually going to come out of that, come back to the home page. I'll go back into that dashboard. So as a user, okay, this is a really good introduction. I've wanted some specific questions for my team, so I've sent this off just for analysis, and maybe then to check those numbers. And then we've just got some examples here we thought quite interesting. So how long have users spent cycling? So a long time is the answer. So 1,000 years, which is pretty crazy. How far have they cycled? So 1,600 times around the world, which is pretty cool. Where are people cycling? So again, top 10 is really nice. Lots of different visualization styles, as you can expect. Nice geospatial, which I'm going to show you in a bit more detail on here. So we've got the top 10 non-returning cycle journeys. That's interesting. Where those are kind of, so lots. This is Hyde Park, I think. Yeah, so you can see lots of people strolling around Hyde Park on their bike. Longest rides, so nighttime rides tend to be longest. Don't know if that's because people get lost or I don't know why. Cycling slower, who knows? But cycling back from the pub, yeah. Yeah, so that's interesting. So that gives you an idea of what it looks like, I guess, from a user's perspective. So one thing we did with this cycling scheme data, which we thought was quite interesting, is we wanted to do some clustering on it. So applied some machine learning, which I'll briefly touch on. We cover this in detail in our second series, but I'll touch on how we did it. If I fire this up. So what this is basically looking at, once it loads up, is we're looking at obviously a map of London. So there's maps across the entire world, but we've looked at London because that's where our cycle scheme is. And what we wanted to do in this example is we wanted to cluster the stations into 6 buckets based on the proximity to the center of London. And you can see each of those buckets has a different color. And you can see the way there's that nice kind of clean radius as it goes out to the black ones on the edge. Now, I want to just touch on, I guess, how we did this. So we did this involving the following technologies. So if you imagine we had that raw cycle journey data in BigQuery, which I touched on earlier. So we had the stations. Included in those data items was the longitude and latitude of those stations. So the first thing we had to do is some feature engineering. So we had to basically calculate the distance from each station to the center of London. So we did that. All those calculations is in SQL, very, very simple. And all of those pipelines we handle in dbt. Now, in order to do the clustering, we use BigQuery ML, and we use a machine learning model called, so we use a k-means cluster in this example, which is an unsupervised learning technique. So basically, the machine learning algorithm buckets those for us. So we don't have to think about working out what the ranges are. If you imagine if you didn't have to ML, you'd have to work out your kind of boundaries to get an even spread. Well, that's exactly what BigQuery ML did for us in this case. The end result is in BigQuery in a table, and then Looker is basically sitting over the top of that. So hopefully that makes sense. 2 minutes on BigQuery ML. If you've not come across it, it's BigQuery ML is a way of doing machine learning on Google Cloud using SQL. So just like if you create a table or a view, you can create a BigQuery model. Really, really good. Like we absolutely love it. We use it all the time. In fact, we use it where possible. And this is what traditionally happens, which is, I said in the last webinar, it's crazy. We're already calling data science traditional. So it hasn't been around that long. But yeah, typically this is what your data scientists will be doing. You'll be doing all these different things like data engineering, sampling data, programming in Python, etc., working out how to productionize it. All of this stuff, the actual value add is very limited when you look at all those activities. In BigQuery ML, if I show you that model, this is that exact model I just showed you. That's how I train it. Now, we've done a little bit of hidden some of this in a macro in dbt. It's actually a dbt model, but basically you can see my select statement down here. So, I'm taking the station ID, I think that is. Oh no, sorry, that's the, what is that? That's the actual journey, isn't it?
I think this clustering was something that was slightly different.
Oh yeah, I was going to say this is a slightly different use case actually, but you can see here these are my features. So when we talk about feature engineering, simple select statement, and then the actual logic for a k-means is it's like create model as in the same way as you do like a create table as. So really, really simple, and we've even further simplified it in DBT using these macros. So you can't get any simpler really in terms of ML. Yeah, and that's our output. And as I said, using BigQuery ML to actually train a model, and then in terms of productionizing it, so in terms of putting that into a production pipeline for doing that clustering, because it's SQL, this lives alongside all our other ones inside DBT. So super, super simple, super easy to maintain. Now you can do that in Looker, so it's worth explaining this. So Looker has persisted derived tables. So the idea of this is in your LookML layer, as well as being able to kind of describe tables that exist. So over here in BigQuery, if I have a presentation layer, so I've got 10 tables, I set up my LookML layer and describe those 10 tables. Looker does allow you to create your own tables, if that makes sense. So if you think about, if you had 2 raw tables and you wanted to create a fact table, you could do that within Looker. So you could define those transformations, and then Looker would actually output tables, physical tables, into BigQuery. You can also create views as well. Now, from a personal standpoint, we actually think it's better to move that logic into a tool like DBT. 2 reasons, really. One is that means that if I calculate those facts and dimensions here rather than in here, if I want to do some data science and I want to pull data out, that I don't necessarily have to go to Looker, because that can be quite difficult to get out from a data science perspective. I've got them defined here. And the other thing that we like about using DBT specifically is for free, you get these lineage diagrams. So this pink, imagine this pink square here. Every square on here represents either a table or a view on your database. And this pink one at the end is my fact. Say that's a journey fact in this example. And all of these tables are all of the kind of transformations that are required, right from our source data on the left here through, we use a layered approach. So we use a raw, clean staging and then a presentation layer. Yeah, I can easily see that. So we really like that. And there's a reason to kind of use DBT coupled with BigQuery and Looker, you get a really good architecture. If I just go back to this, so yeah, now we're just plotting this in Looker, which is really simple. All these maps just come straight out of the box. Now this is quite interesting. So we are using machine learning again. We asked it to, this time, just to put them into 6 buckets based on where they are. Okay, and you can see the 6 buckets on the left and then another 6 buckets on the right. Now the difference here that we did, so we used normal longitude and latitude here on the left. But the nice thing with BigQuery in particular is it comes with a really good geospatial data type. So we clustered using the geospatial data type on the right. And you can see, because we were interested in actually as a team just to see what the difference is. And you can see actually the clustering is more accurate. So using long and lat, you get these odd outliers, like these 2 red here, which I'd argue don't really sit within there, in that cluster there. Whereas you can see this has clustered it differently, but I think that actually the clustering looks better. You also get these odd ones here, right? This looks very odd. So geospatial data type in BigQuery is really, really useful. You can do some really cool things with it. So for example, I've seen worked with a retailer, one of the big supermarkets in the UK, and what they were doing, they were defining polygons for the car parking areas where their delivery vans go in their stores, and they were actually separating those into different bays. Then you could write queries that basically said, if you took your long and lat of your van, you say, is it in this parking bay? How far is it from the parking bay? You can, again, just using SQL, you can write statements like that, which is really, really nice. If you think about how you would do that using just long and lat, that's actually quite a difficult problem to solve. Yeah, here we've got another example of tube stations. So we've got cycle stations close to the central line in this example, so you can see that line running across. You can do some really cool things. We've got some nighttime one here, so you can do full customization on look and feel. So we often brand these to our clients, branding. This is a real life kind of business problem with the cycle schemes like this, or electric scooter schemes, which are growing and popping up all over. If you ever visit LA, check out electric scooters. They're really neat. You're going to see these, I think, popping up in a lot more cities. But the problem they have is, and if you're familiar with London, you'll know this, is they have lots of surpluses and deficits at various stations. So if you imagine a cycle station next to, say, Waterloo, 8 a.m., loads of people are going to be taking bikes away from there. So the problem is, we call him Bob the van driver. Basically, he has to make sure he moves bikes from the surplus station. So if lots of people cycling to, say, Soho, like as we saw, you imagine the terminals get full. If you've got 50 drop-off points, they get full, and then people would start leaving bikes everywhere, or they have to go and find another terminal. So these guys in the vans are basically spreading out those surplus and deficits. So what we did here is we thought, okay, well, what you could do based on the intelligence, we can actually use, so again, we use BigQuery ML to predict the next day's surplus and deficits based on an hourly kind of time frame. So then the idea was that we thought, well, this would be really cool because we've got Bob the van driver. You could serve these analytics. Bob knows at 8 a.m. that these are his surplus stations. These are his deficits. And he's basically got his shopping list of where to basically move bikes from and to. So really, really simple. Again, for 9 a.m., 5 a.m., 6 p.m. Now, there's a number of different ways you could get these to Bob, and I guess this is where we kind of touched on earlier. So you could schedule this, that'd be one option. So you could schedule this dashboard. I could go up to here like we did before. I could email this to Bob. I could email it as a link, and he fires this up and sees this in his browser on his phone. If Bob's a bit more old school, he might actually like to print it out and cross it off. That's fine. We could send it as a PDF, and Bob prints it out. Has it with him and chalks it off. Hopefully, if Bob's going to be a little bit more, I guess, data driven, where we want him to get to, is we could write a custom app for Bob. You can imagine taking this to a further degree and actually doing route planning for Bob, so which would be pretty cool. Now, in order to do that, this is all now possible and made really simple by the fact that Looker has that API. So you can imagine that we do some ML, so some kind of route planning, build up Bob's day, and then we could write an app or use something like the Google Maps API, and then actually pull that data from Looker's API and then serve it to Bob in his hand on his phone. We can also feed back as well. So if Bob's done a pickoff, he can mark it as done. If there wasn't a surplus, we could start actually feeding stuff back and actually getting the data back in and maybe improving that ML model. So yeah, so that's just an example there with scheduling, and I guess how that can then extend to that embedded use case. Okay, I'm going to do another 5 minutes and then I'll hand over to Bailey. But another use case that has some quite good features of Looker is our CFO Lab product that we produced last year. So but basically lots of companies out there were kind of struggling with cash flow. There were lots of changes during the pandemic. Things like revenues were changing, costs were changing, staffing, furloughing, all this kind of massive change. And I guess it still continues now, which is kind of crazy considering how far on we are. And companies were just really struggling. Two things. One is to get a handle on their cash flow. And two is to model lots of different changes, whether it's to payment terms or staffing models. And the third is actually building forecasts. So they wanted to forecast and say, how much cash have I got, in 3 months' time, 1 month, 6 months. That was really difficult, really time consuming. So we built this product. And what this kind of follows our methodology. So just to give you a background before I show you it in Looker. So we're ingesting data, typically use Fivetran. So if someone's using Oracle NetSuite, for example, which is quite common, all their invoicing data, i.e. their accounts, live in Oracle NetSuite. So we use Fivetran, which is a zero code ingestion platform, just to bring that into BigQuery on an hourly basis. And then we have some Google Sheets that the CFO can actually use to model those kind of what if scenarios. So we ingest all that into BigQuery. We do a ton of complex transformations in dbt, coupled with BigQuery ML and AutoML for machine learning workloads. So all that's happening in dbt, all happening in SQL. And then we've got an analytics layer, and that's then serving it to the end user. So what we have here is we have this idea of my cash flow. So you can see invoiced in total, 33 million. This is just random data that we've produced. But you can see my payments, my credit notes, outstanding. So I've got quite a lot of payments here overdue. Shows me my top 10. If I come down here, I can go down to the invoice level, which is on my overdue invoices. As I mentioned to you earlier, with the LookML level, you can do LookML layer. You can do some really cool stuff here. Like, for example, clicking on this will actually take you to that invoice. So if you're using something like QuickBooks or you're using something like Oracle NetSuite, you can use these hyperlinks in your viz to bring you into that raw data in that raw system. It's really easy to define these. You basically can define HTML in the LookML layer. So you can go crazy with these if you want. You can have JavaScript buttons, spinning around if you really want to. But I mean, this one just kept it simple. It's just a link, but it's actually really, really powerful. So tabular data, Looker does really well. Don't be afraid to use tabular data. So visualizations are good, but also tabular data for things like this, I still think have a really good place. And then here we've got the data's a bit out of date now, but we've got this will show your upcoming payments. And this is using machine learning. So CFO Lab uses machine learning to basically say, okay, you think you've got 1.6 million coming, say, in the next week, but actually we predict that, in this case, 18,000 of that's actually going to be late. So we're using ML to kind of do that, to help with that forecasting. So nothing due, and lots of other different visualizations there. Final bit I wanted to show you this is probably a difficult use case for visualization, is displaying these forecasts. So this is a forecasting element of CFO Lab. So what you basically do, if I show you this, if I open a new tab. So CFO comes into this spreadsheet, and they can basically tweak real time a scenario. So if we look at our config, we've got some high level attributes on here, current cash balance, when my payroll dates are, for example. So it's CFO, I key those in, and then I can customize payables. So this is money going out the door, and I can do things like change term days, I can have payment plans, etc. So I can tweak that on the payable and receivable side. I can enter new payments and whether that's money going out, money coming in. I can do recurring payments, and then I can change my payroll, including, for example, furloughing staff. So I can, as a CFO, I can tinker all of these. I can create what I think is going to be a scenario, and then when I come into CFO Lab and actually run this real time, that sheet is linked to BigQuery Live. So if you imagine, this is actually computing the culmination of my invoicing projected with those changes, and then produces a forecast. You can do some quite cool visualizations like this one. So this is actually showing what my cash balance looks like as a result of that forecast. So yeah. So where are we at the moment? So we're kind of around here, aren't we? So the blue ice line is the cash flow. It's the cash balance. So you can see it's not looking good, right? We're getting 25 million in the red there. And then we show things like individual staffing costs, deferrals, etc. But yeah, so look at just out of the box handles these kind of quite complex visualizations we think really well. And you can do, obviously, like the normal things you can do in any kind of modeling tool, viz tool, sorry, you can do filtering, etc. And you can define all those up on there. So yeah, so I just wanted to touch on CFO Lab just as another kind of use case. Right, and the final thing I wanted to just touch on is embedded analytics. So we use the I guess, Bob, the van driver example, the Santander scheme, how he would serve those analytics to his phone. So that's what when we talk about embedded analytics, that's what we're kind of referring to. Another client, another real example of that we're doing, working with a major city in the UK at the moment to build a smart city data store. So we're ingesting lots of information around electric vehicle charging points, CCTV cameras, transport, IoT devices, event data, doing a lot of machine learning, other analytics in BigQuery. And then we're presenting all of this in an analytics layer in Looker. And like we talked about, hopefully it's becoming clearer. So defined once, so we define a KPI once, and we're serving it in different channels. So some people are using Looker, as I've showed you. Other use cases, so for bus terminals, having smart terminals looking at where the buses are, for example, that would be a custom app you can imagine hosted in that, in that LED screen. That's basically making calls to the Looker API. And in a similar way, if it's a really custom app, a mobile app, then again, you can make API calls. Or if it's, if it's just we wanted to surface some of the visualizations, we're also going to be either just having Looker branded to this city that's just hosted in an iframe. So there's actually very little development. It's just literally just a hosted page that renders really well on a mobile. So yeah, so that's another really good and relevant embedded use case. Okay. I apologize, I thought that was my last one. One more was the custom actions and workflows. I touched on this before, but you can, using custom actions, you can do some pretty cool stuff in Looker. You can basically almost turn it into a lightweight application, really. So you can, for example, define a button or define a form. So if I click on a button on a dashboard, it will present a form. Maybe I need to capture some information. I can make an API call, and then I can essentially, using the API again, I can almost like serve or create a dynamic application. So if I wanted to write some data back, for example, like that Bob van driver example, I can have a custom action that actually writes data back to BigQuery. So you can start to build some pretty cool apps. It's not just passive reporting, which I think some of the other products kind of suffer with. Yeah, this you can start to create, two-way engaging data platforms. So they're really good, really easy to see. Right, so I'm conscious I've been talking for a while. So I'm going to hand you over to Bailey now, who's going to show you a bit of, the actual LookML kind of development.
That's right. Just sanitize up there. So in this part, I'm going to take a deeper dive into the back end of Looker and how those wonderful dashboards were created. As James explained, Looker has a semantic layer called the LookML, and this is where you describe how Looker should be interpreting your data in your data warehouse. So when you come into the LookML, this is how it looks. I want to make sure that I'm in development mode for this, as I'm going to be adding some today. And what we can see here is a model file. We've also got view files. You can also have dashboard files as well. And these are all version controlled within a Git repository. The model files contain information about which tables to use and how they should be joined together. And the view files contain information about how to calculate measures and dimensions in the tables themselves, or across multiple tables if the join permits. Dashboard files, as you might expect, they are describing how the collection of looks are all displayed on the dashboard. It can be very useful to use dashboard LookML files. For example, if you've got some that you were testing or deving, and you want to switch them over to production. If you're quite savvy with the LookML, it can be a fair bit quicker to control find through the LookML, change a couple of bits and have it point over towards your production side instead. What's great about the LookML, as James explained, is the single version of the truth aspect it provides. You write the code in one place, and it allows business users to generate ad hoc SQL queries on the fly. Again, for the business user standpoint, the end result is that you're able to build really complex queries in Looker, but with absolutely none of that knowledge required. So it's fantastic for enabling the self-serve model. And for a technical user, the LookML syntax has a structure which is very clear and easy to learn, particularly if you're fluent with SQL already. For example, you can see this join here is very, very similar, and it will come quite naturally to you. So jumping in, I've already turned developer mode on, and I'm going to get started and create a new view file. So I'm going to just add up here and create a view from a table. So this is going to use the connection that we've defined here. It's going to look in our sandbox BigQuery project. And as you can see, we've got quite a lot of data sets in here actually. So I happen to know that the one I'm looking for is in reference. And I'm going to pull through our dimension table for the cycle stations. So I just selected that one and I'm going to create view. So that comes into the views folder straight away, and you can see that Looker has auto-generated all of this LookML for me. It has looked at the schema within BigQuery. It's looked at the data types to infer all of this. We can see different types, numbers, strings. What's also quite cool is this date type as well. Looker automatically breaks this date field into various other informative fields, like we can extract the week, month, etc. from that just straight away. So a couple of edits that I want to make to this one. In this column, I want to tell Looker that this is the primary key for the table. Do that just by adding this one here. See that the IntelliSense is predicting that's what I'm going for. So just go ahead and tell it that's the primary key. The reason that I need to do this is it helps Looker avoid unnecessary group by clauses, and it's also key to letting Looker solve the problem commonly known as fan out. So if you join a view with measures, like we've got here, by count, for example, aggregating this number in a join might end up going a bit awry. Looker with this primary key field, in addition to the relationship with the join we'll find later, manages to completely avoid that. So I've added the primary key here. Another quick edit I want to make is on this distance from the centre of London. As James mentioned earlier, we want to make things clear to our business user what every field is. So I'm actually going to apply a label here, and I'm going to make it very clear to the business user that the units for this are miles. So we're going to just label this miles from centre of London. This field is built off using Trafalgar Square as the centre. And a bit of feedback that James mentioned earlier was that this dim table had two name fields. It had just one called name and it had one called terminal name. So again, just to help our business user, we're going to mark this as a hidden field, so that we won't have those two tables confusing us when we come to explore it. So with those changes made, I'm just going to go ahead and hit Save Changes, and now validate the LookML. This built-in IDE is excellent for debugging. If you have a LookML error that will stop it from compiling, it'll be very, very explicit in telling you what's wrong and what you need to change. In addition, what is very useful is IntelliSense, as mentioned, and also there is this information panel that gives you just some quick help on all of the different parameters which can go in each of the sections. So on this outer layer, dimensions can be added, as you can see, look, is automatically done. And in these dimension brackets as well, there's all sorts of other ones, like the primary key field I added, as well as the hidden option as well. And all of these link out to documentation as well. Look has got very comprehensive documentation on LookML. So I would say that it's a language that is very easy to pick up, user-friendly indeed. So with that saved and validated, what I could do is commit these changes and push to the remote. The Git terminology there is going to allow other people to use the LookML I've developed in their own personal branches, or perhaps on production if we additionally push to production afterwards. As you can see, it's mentioning that we're on James Green's personal branch here. So any changes that we currently make at the moment, any breaking changes perhaps, will not be visible to any users until we do that final push to production. So with this dim cycle station view produced, I'm just going to create a new, we know that's fine, a new explore so that we can go ahead and play around with that. Quite similar to this one, so I'm going to comment it out for now. So I'll start on this at the bottom. The table that we're kind of using as the foundation for this one is that same one. So I'm going to just start by basing it off the snapshot hourly station table. And for end user usability, I'm just going to provide it with a bit of a nicer label. I'm just going to provide, give cycle hire demo explore so that we can easily recognize it later. Now I'm going to join in the dim cycle station table that I just imported. So I'm going to join that in here. I just need to give it the same name that's defined over in the views folder. So dim cycle station. And as with I would do in SQL, I would tell it how that is joined on, which I do with just a SQL on parameter. And I'm going to use, because substitution syntax, when you see a $sign here, that's what it's doing. It knows what to substitute out this table and field name, interpreting that into BigQuery. So I know that I want to do that on the cycle station natural key, and I'm going to join that onto the snapshot hourly. And I'm going to join that onto the cycle station natural key on that side as well. So in SQL, that might be all you do. You just define how it works on each side. But in Looker, as mentioned with the fan out problem, the primary key was only one part of solving that. And the other part of solving it is to define the relationship between those two tables. So if I think about how the rows interact, I might have many different journeys linking to one station. So that tells me that in this case, I want a relationship of many to one. In a different scenario, if you just had one row in the left table joined to one row on the right table, then your relationship would be many to one in that case. So that is that join successfully done. But I'm also just going to join in one more, and I'm going to join in our date dimension as well. Similarly, defining the relationship many to one and doing the SQL on statement. This one is going to be done via the date, as it is our date. We have a raw one, there we go. It's on date actual raw, that's the one. So going to go ahead and save those changes, make sure it's all good. Fantastic, no typos there. So this is now ready for me to use and explore. So I'm just going to come out of the LookML IDE, back to the home page, and now under this Explore option, we will see this Demo Explore has appeared. So as James gave the example here, I can now go ahead and self-serve just to demonstrate that we now only have one name field, a little bit more user-friendly, having hidden that terminal name. I could go through and pull through any field I wanted. If I might want to go for just the hour of the day and just take the activity at the hour of the day. So journey leave count would be a good measure of that, and just take the sum of all the journeys. So total journey. So this custom measure I'm defining here, I am doing it through the UI. If I wanted to do this in the LookML, that is also another option to really give that single source of truth real feel. Typically, you might not want to allow business users to have their own measures, in which case you would have those predefined in the LookML for sure. So let's just go ahead and save this. We don't need to save it. We've got plenty of examples of other dashboards. So I'll just go and pull up one such example. The cycle schema view is a familiar one. One of the options in the drop-down that we didn't explore earlier was the Get LookML option. So from this, I can just get the LookML for this entire dashboard, long as you might expect. So what I can do is, this would be useful for what I explained earlier about copying from our dev environment to a prod environment. We would just adjust the connection that is used in here. It'd be a very quick way to keep it version controlled and import it across. So that's my dive into LookML and developing those. And yeah, I think that kind of wraps up my part there.
That's great. Yeah, thanks Bailey. Yeah, so Bailey, I mean, when you learned Looker, I mean, how did you find the learning curve?
Yeah, knowing SQL already, I found it was pretty easy, particularly those that kind of IntelliSense that the IDE provides. Lots of links out to the documentation.
Yeah,
it's very quick and easy to pick up. Yeah, for sure.
Brilliant. Yeah, I just want to say thank you, really. Thanks to Bailey and Nanor for helping with the presenting, and thanks to you guys for attending. Hope you got something out of it. Hopefully you enjoy. For some of you we've noticed have followed all the sessions, which is great. Yeah, I hope you got something out of there, and just always advocate. Go start doing some of this. A lot of this stuff is free, as I say, for trials, so you can get a BigQuery trial, Looker trial, DBT trial. Away you go, start building it. And if you need any help, then feel free to get in touch, and we can help you. So yeah.